Prior to getting down to the modeling step, let's consider some features of the Revit user interface. When we run any given command, the user interface undergoes certain transformations. Let's take the Create Reference Plane command as an example. The first thing to happen is Revit switching us to the Modify tab. The tab itself will also be slightly modified. The right-hand side of the ribbon will always contain a number of specific commands related to the selected tool, and the bar below the ribbon will display a number of additional options. The Properties panel will also change, and the features of the object we are creating will be displayed. Last but not least, the mouse cursor will change. Instead of the usual arrow, we will see a special symbol. For instance, the crosshair cursor is used to create reference planes. For other commands, the sign may be different. For example, let us select the Aligned Dimension tool. We see that the mouse cursor has changed, as well as the set of commands on the ribbon and the Properties palette. Similar user interface transformations take place when certain objects are selected. I press Escape twice to reset dimensions and switch to Create tab. If I select an existing dimension, I will also be switched to the Modify tab. The tab itself will display tools related to the modification of the selected dimension, and its properties will appear on the Properties panel. The mouse cursor will remain the same. It doesn't change while selection. Now that we know it, let's proceed to modeling. Revit supports 3 object modeling techniques. The first technique is line-based object modeling. We create a line and shape geometry along this line. It's in this way that we create reference planes or walls. In the same way, we create sections of pipelines, air ducts, or cable trays. The second technique is point-based modeling. We set a point in the model space, and the geometry is formed at this point. We use this technique to create columns, pieces of furniture, or equipment. In the same way, we can create utility system fittings or fixtures. Last but not least, the third technique is sketch-based modeling. A 2-dimensional sketch is drawn to be transformed by the software into a 3-dimensional geometry. This technique is used, for example, to create stairs, fencing, floors, roofing, as well as all the 3-dimensional geometry elements in the Family Editor. The list of these elements can be found in the Forms panel of the Create tab. These elements include extrusion, blend, revolve, sweep, swept blend, as well as equivalent void forms. We need void forms to cut out of the solid state of geometry. We are creating a cube family, or more precisely, a right-angled parallelepiped. To accomplish this task, we will need a basic 3-dimensional form, the extrusion tool. By clicking on this tool, we will switch to the sketching mode. In this mode, all the other objects in the model space fade out. Similarly, many ribbon tools become unavailable. For example, we see that the cut and join buttons have become inactive. If we switch to other tabs, we will also see some unavailable tools. There is only one way to leave the Edit mode, by clicking the cross or tick icon in the Modify tab. By clicking the tick, you accept all the changes made in the Edit mode. By clicking the cross, you cancel all those changes. Once you have left the Edit mode, all the objects become bright, and all the ribbon tools become available again. Let me click Extrusion once again. Different rules apply to different Revit tools in the Edit mode, but in fact, we always have to create a flat sketch. For the extrusion geometry, the sketch of a set height in the downward or upward will be extruded, and thus shape a 3-dimensional geometry. Since we are creating a right-angled parallelepiped, we are required to use a sketch of a rectangle. In the Edit mode, we can see various tools on the Draw panel. These tools include the rectangle that we need. Let's select it and attach it to the point of intersection of 2 reference planes. Then, going diagonally to the point of intersection of the 2 opposite reference planes, and thus complete the creation of a rectangle.
lock icons will come up. These locks need to be closed in order to establish a link between the reference planes, which serve as basis for our sketch, and the lines of the sketch. Without such a link, the sketch will be separate from the reference planes. That is, if any changes are made in the parameters, the reference planes will shift, while the lines of the sketch will stay where they are, and the geometry dimensions will be constant. However, if we establish a link, any shifting of the reference planes will lead to shifting of the sketch lines, changing the extrusion geometry that is created based on the sketch.
This linkage technique, where we create a rectangle and immediately close the locks, will only suit us if we are dealing with a regular shape. If the shape of our sketch were polyline, we would not be able to come up with a ready outline right away. In such a case, we would have to employ another technique.
Now I will press Escape twice. Select the sketch and delete it. To demonstrate other sketching techniques, I will use the Pick Lines tool. This tool allows to create lines above existing objects. For instance, on reference planes, we can set a lockbox in these tool's options. When the lockbox is set, the sketch lines automatically get attached to the objects they overlay. I'll point the cursor over a reference plane and left-click it. There will be created a line with the closed padlock. Then I do the same for the other reference planes. This sketch is not ultimate yet, because its counter isn't closed. For an extrusion, it's critical. If I try to finish sketching, an error message will pop up saying, "Lines cannot intersect each other." In case of such an error, it is necessary to click Continue and correct the error. In this particular case, I have to get rid of these tails. To do it, I use the Trim Extend to Corner option. Then I click the pairs of lines one by one. Another potential sketching error is having two lines in the same place. Let's create another line overlaying a reference plane.
Sometimes, when such a problem occurs, Revit alerts the user right away. However, this warning message can easily be unnoticed.
Now I will try to finalize my sketch. As we see, the same error message has popped up. Lines cannot intersect each other. The problematic area is highlighted. I click Continue.
Then I reset Trim Extend to Corner command by double-clicking Escape.
After that, I draw a selection box to select one of the highlighted lines. The Properties panel shows that one of the sketch line is selected.
Similarly, I select the other sketch line mentioned in the error message.
The Properties panel is indicated that two objects are selected at a time. I need to delete one of them. I select it with the mouse click and press Delete. To check the correctness of the linkages I've established, let me select one of the lines. The lines that are attached to the reference planes have lock icons, but there is one line without a lock. This problem occurred when the redundant line was deleted. To get the lock back, the Align tool can be used. I click the reference plane, then the sketch line, and then close the padlock. Now the sketching is done correctly. I finish the edit mode. A three-dimensional extrusion geometry will be formed. Let's make sure of it with the 3D view. Go to 3D view by double-clicking View 1 in Project Browser. The 3D view will open up. To pan it, I press and hold down the scroll wheel and drag it. To rotate, I do the same. I press and hold down the scroll wheel and drag, but this time I'm also holding the Shift key on the keyboard. To zoom the object in and out, I rotate the mouse scroll wheel. We can see that the extruded sketch has a set height. The height is defined by setting the extrusion geometry properties. namely the extrusion start and extrusion end parameters.
These parameters mark the upper and the lower faces of the object.
If extrusion start is set as 0, the height of the object will be defined by the extrusion end value. Let's try to change this value. Nothing happens when I set another value and press Enter. Properties only become effective after you have clicked the Apply button on the Properties panel, or after you have removed the cursor from the panel. In this case, the Apply button is clicked automatically. We can see that the height of the object has changed. More complex families may consist of several geometric bodies. They can be different extrusion, or combinations of different forms, for instance sweep or blend forms. Therefore, it would be inaccurate to say that the extrusion end setting determines the height of our family as a whole. It only determines the height of this particular form. Nevertheless, we can associate this property with any parameter of the family, for example with height. While doing so, we determine that for this particular form, the value of extrusion end will coincide with the height of the family. This is done by associating family parameters. Let's click the Associated Family Parameter button on the Properties panel. Extrusion end can be associated with either length or width, or we can create a new parameter. Let's do it. Let's call this new parameter height. Once again, I set the instance position and click OK. Then I select height and associate it with extrusion end. Once it's done, the property value will be blocked and we will see the equality mark on the Associated Family Parameter button. Now let's make sure that it has worked out. To do so, I switch to the family types and change the height value randomly.
The same family parameter can be associated with several properties of different objects and forms within a family.
Moreover, this may be done not only to geometry characteristics. I select the extrusion geometry once again. Let's associate a family parameter with the material property. This time, there is no length, width, or height on the list. We are gradually approaching the notion of data types that can be present in parameters. We'll discuss that later. And now it will be enough to understand that the parameters length, width, and height are just inconsistent with the property material. Let's create a new parameter. I will call it cube material. In this case, we put the toggle position on type. Then I click OK. Select the parameter and click OK once again. The property will be locked and the equality mark will appear on the button, and the new parameter will show up in the Family Types window. The family is ready now. We only have to save it. Let's click the File, then Save As, and then Family. Now we have to choose a name. I will call this family 000_cube, and then click Save. When an existing file is rewritten, backup files will be created for the previous version. A backup file always has a suffix with a numerical code in its name. The updated version of the file doesn't have such a suffix. Thus, you can always open the previous version of a file or fall back to it. The possible number of backup files is defined while saving. Now let me change options. In this case, after the third saving, the first backup file will be rewritten.